Welcome back for more about circles. And I get a question every now and then about why I always start at the beginning of the notebook and flip to the right section. That is because I want you to be sure that you're in the right section of the notebook. Also, we have several courses going. It's not just geometry, so I want to make sure that you're in the right notebook if you have more than one. So we're in the geometry notebook. We are talking about circles. So go to the circles tab. And remember last time we talked about the anatomy of a circle and where pi comes from. And now we're up to a page about circumference and area of a circle. And then we have a couple of exercise pages that I'll probably put on another video. Okay, the circumference formula. Let's start with this one. And you can really do this two ways. It depends on the test, the teacher, the book. Different books do things differently, so I'm going to show you both ways in case you encounter one of these in another course. But the first one, I'm going to use, let me give you a radius here. I need a straight line. So let's suppose that our radius on this problem is 10 feet. So maybe this is a garden in my backyard and I am putting a fountain in the middle of the garden. So the fountain is going to sit exactly in the center of the circle. And from this water fountain to the edge of the garden is 10 feet. And remember what circumference is. Circumference is the distance around a circle. It's like a circle's perimeter. Perimeter goes with angular shapes, but circles have circumference. So maybe in my garden I want to put a fence around the circle to keep the animals and the kids away from my fountain. So I need to know how much fencing I'm going to need. And I'm just making up a story to help you understand what's going on here. Okay, in this formula, I know R. R is the radius. Okay, so the circumference formula that I will use here is circumference equals 2 pi R, because we know R. So when you fill in this formula, the distance around the circumference is 2. Pi is a letter, so we put a pocket there. It's a Greek letter, but it's still a letter. And remember from the last video, we're using 3.14 for pi. And then the radius of my circle, of my garden, is 10 feet. So here's the formula that you need to type into your calculator. So we're going to say 2 times 3.14 times 10 equals 62 8/10 feet. So if this is my garden and I'm going to do fencing, I need 62.8 feet to to enclose that shape. So what if they give you the diameter? What if they say, okay, instead of 10 feet for halfway across, what if we give you 20 feet as your diameter? So they give me all the way across in terms of the diameter. So in this case, I could use the formula circumference equals pi times diameter, because I know what diameter is this time. So if you say, okay, there's C equals pi times D, so we would do 3.14 times diameter. So on your calculator, you're going to say 3.14 times 20, and you come up with the same thing. So how in the world can that be? How can I use two different dimensions and two different formulas, but still come up with the same answer? Well, here's the thing. In this formula, I used 2 times r, and in this one, I used plain d. Okay, pi is in both of them. Pi is going to be in any formula that has a circle in it. So that's going to be something that we just have to get used to. But 2 r's and d are the same thing. 2 times a radius is the same thing as the diameter. So 2 times the radius is the same as diameter. And that's why these two problems are working out. 2 r's are the same as one of the d's. And you can see that in this picture. 10 is half. 2 of those make the 20. So 2 times the radius is the diameter. You can use either of these formulas. I learned the bottom one and I use it all the time. I just work with r and d as necessary. But I wanted to show you both of them because it's possible that you'll see both of them, and then you'll have something to come back to if you do. Okay, let's look at area of a circle. And this formula is a little more complicated because we're looking at the inside of the circle. How many of those squares does it take to cover the inside of a circle? So let us pick a radius and a diameter. We'll do one of each. This time I want to start with diameter because I don't want you to think one is more important than the other. And this time I'm going to bring the diameter this way because it won't always be where you think it would be, but it is going all the way across the circle. So the diameter of this circle, I'm going to go wide and say 50 miles. And I'll give you a story for this one. Let's suppose that we have a prison escape at the center dot. Let's suppose that some prisoners escaped from the prison and they started running. Probably the first thing the authorities, the police, are going to do is set up a search area. They're going to go out in all directions the same distance. So the diameter of this search area is 50 miles. From one edge of the search area to the other edge of the search area through the prison is 50 miles. So what we're looking at is how many square miles are going to be contained in this search area. And I'm picking that example because I want to use miles, and that's the only thing I could think of that would require marking off this amount of space. So let's see how much search area we have to cover. So the formula for this particular one is A, and here's our old friend pi, r squared. A equals pi r squared. So I go to set up my formula. We're looking for the search area. We know about pi. Pi is constant. It never changes. But here's a problem. I don't know R. I know D, but I need to put R into my formula. So I have to come over here and find R, and I know that I cut that 50 in half and I get 25 miles. So what we're saying is that from the prism to the edge of the circle, the search area, is 25 miles. And let me draw that a different way. Let's go this way. Half is 25 miles. And that's what goes into the formula. You can't just put D in there. It has to be the radius because that's what the recipe asks for. You can do this on your calculator. I would encourage you to take one more step right here just to cut the possibility of some mistakes. 25 to the second power is 25 times itself, and that's 625. And then go ahead on the calculator and multiply that by pi, and you'll have your answer. But I recommend doing the exponent before you try to do pi. That's just a lot to keep up with. So when the prison brings in the search team, they're going to need a lot of manpower because we are searching 1,962.5 square miles. This is a huge area for people to cover. So that's an example on a very large scale of area. And this is a pretty complicated formula because this is a complicated shape. The shape is not just your basic nice square. There's a lot going on with this circle. So that's a very large area problem. Let's do a very small one. Let me tell you a different story on this one. Let's suppose that I work for a company and they have asked me to, this would never happen because I'm not artistic, but they have asked me to design a logo for our company shirts. They want to buy everybody in the company a shirt and they want me to design a logo. So I take the shirt and I come up with a plan for making the logo. But it has to be pretty small. It's got to fit on the pocket on the shirt. So I have to make this a very small area to be covered. And I know some of you may be used to the metric system, so let's do one of these in terms of centimeters. So maybe my logo turns out to be 4 centimeters in total. That's going to be 2 centimeters for the radius. Again, the diameter, if you wanted to look at the whole distance across, the diameter would be 4 centimeters. So radius is 2, diameter is 4. And this is a little bit over an inch. 5 centimeters would be about 2 inches, so we're really about 1.5 inches, somewhere in there. This is a very small circle. The one that you saw right before was representing miles. This circle is representing a very small space. It's probably not much bigger than the real circle we're looking at. So let's figure out the area of our new logo. How much of the pocket of the shirt is going to be taken up by our new logo? So we say area is pi times radius squared. You know about pi. And if folks are going to miss this problem, this is where they miss it. What goes in for R? It's the 2. 2 centimeters is radius. Again, you can put this in your calculator like that. There's a problem on the calculator tutorial that looks similar to this, but I strongly recommend going ahead and working out the exponent. That's just a habit that I have. You certainly don't have to do that. You're adults. You decide how you want to do this. But however you do it, you need to multiply pi times 4. And that's going to give us 12.56 square centimeters for this logo design. Okay. So it doesn't matter how big the circle is or how small it is, the math is going to be the same. So the formula doesn't change depending on the size of the circle. Okay, I'm going to stop this video. I'll see you in the next video for some word problems, and then we'll be finished with circles.